In our second video, we're going to be analyzing the h function and the j function. H of x is read is equal to 2 times a quantity, take away 6. And our j function, j of x, is equal to a quantity, x plus 6, is divided by 2. So again, we're going to be taking a look at the composition of these functions. We can see that there's some similarities and some connections that we can draw upon, but we're going to see how they behave when they're composed within each other. So our first example is going to be taking our h function, and we're going to be inputting our j function, and it's usually read h of j of x. J of x is composed within our h of x function. So we take a look at what j of x is, and we place it as the input within h of x. 2 times the quantity, x plus 6 divided by 2, take away 6. And you can see that if I rewrite it, 2 times 1/2 of x plus 6, take away 6. That there are some multiplicative and additive inverses of each other. 2 times 1/2, or 1/2 of 2, is the multiplicative identity. There is a 1 pair right there. So I'm going to rewrite my problem. X plus 6, take away 6. But I see that that also is the additive identity. That creates 6 zero pairs, and I'm left with x. So let's take a look at the composition of h of x within j of x. J of h of x. I'm going to start with my h of x function. I'm going to input it wherever I see the input for my j function, and I can see that there are beginnings to seeing the identity and inverses within this one as well. I can identify if I take away 6 and add 6, well, there's 6 zero pairs. That's the additive identity. So I'm left with a quantity 2x divided by 2. Well, 1/2 of 2x again creates a 1 pair. 1/2 and 2 leave me with a single x. So what do we call h of x and j of x when they're composed within each other both times, they produce the same result? They're inverses of each other. H of j of x is the same as j of h of x because they're inverses of each other and they produce the same answer, x. So what does that mean? X must be the identity function.